Hello, what I want to do in this video is provide you with an introduction to both programming and Python. So a programming language is like a code for writing the instructions the computer will follow. Programmers will often refer to their program as computer code. The process of writing an algorithm in a programming language is often called coding. So there are two types of programming languages. There's the high-level computer languages which are designed to be used and understood by humans. And then there's low-level languages. Computer hardware can only understand a very low-level language known as machine language. Adding two numbers using a low-level language consists of loading the number from a memory location such as 2001 into the CPU. You would load the number from memory location 2002 into the CPU. You would add the two numbers in the CPU and you would store the result in location 2003. So when you're doing low-level programming, you would need to know the exact memory locations where your numbers are in that you want to go ahead and add, and the memory location of where you want to go ahead and store the result. In reality, these low-level instructions are represented in binary or ones and zeros. So in a low-level language, your program would consist of ones and zeros. A high-level language, basically, it's easier to understand by the human. In this next case, we want to add a plus b and save it in C. What happens is this needs to be translated into the machine language that the computer can execute. So basically, after your program has been compiled, it converts your program written in a high-level language into the machine language of some computer. So it converts that high-level language into ones and zeros so the computer can understand what you want to actually do in your computer program. So this is kind of a chart where a language that uses a compiler, you would go ahead, you would write your source code or your program, you would go ahead and compile that program. If there are no compile errors, it would get translated into machine code. You would then go ahead and run your program and enter any inputs. After the program has been run, it would go ahead and output the information. Interpreters simulate a computer that understands a high-level language. The source program is not translated into machine language all at once. What an interpreter does is it analyzes and executes the source code instruction by instruction. So what you have here is you have your source code or your program, you have your input, the computer is running an interpreter, and then you have your output. So basically you don't go through that process where it's compiled and converted into machine code. The interpreter does all of that for you. So compiling versus interpreting: once a program is compiled, it can be executed over and over without the source code or compiler. If it's interpreted, the source code and interpreter are needed each time the program runs. Compiled programs generally run faster since the translation of the source code happens only once. One of the drawbacks with compiled programs, say for instance if you have a very large program that it takes a long time for the program to compile, and you have to fix one line, the only way you're going to know if that line has been fixed is if you recompile the whole program and then run the program. Whereas an interpreter, you can go ahead, enter that statement into the interpreter, and it'll let you know if that statement is correct or not. Interpreter languages are part of a more flexible programming environment since they can be developed and run interactively. Interpreted programs are more portable, meaning the executable code produced from a compiler for a Pentium won't run on a Mac without recompiling. If a suitable interpreter already exists, the interpreted code can be run without no modifications. So what we're going to do is we're going to talk about Python next. So Python is a widely used high-level programming language for general-purpose programming. It was created by Guido van Rossum and first released in 1991. It's commonly defined as an object-oriented scripting language. An interpreted language, Python has a design philosophy that emphasizes code readability, notably using whitespace indentation to delimit code blocks rather than curly brackets or keywords, and then also a syntax that allows programmers to express concepts in fewer lines of code than might be used in languages such as C++ or Java. Python was actually named after the comedy group Monty Python, which is a British comedy group. And then IDLE, which is IDLE, stands for the Integrated Development Environment. The extra L is thrown in as a tribute to Eric Idle, a member of the group. So that is Eric Idle singled out in the picture. Who uses Python? The size of Python's user base is roughly 1 million users around the world. Google makes extensive use of Python in its web search systems. YouTube video sharing service is largely written in Python. Raspberry Pi uses Python as its educational language. NSA uses Python for cryptography and intelligence analysis. iRobot uses Python to develop commercial and military robotic devices. Intel, Cisco, Hewlett-Packard, Seagate, Qualcomm, and IBM use Python for hardware testing. JP Morgan Chase, UBS, Gitco, and Citadel apply Python to financial marketing forecasting. NASA, Los Alamos, Fermilab, JPL, and others use Python for scientific programming tasks. These are just a few of the various enterprises that use Python as a programming language. What can you do with Python? You can do systems programming, GUIs, internet scripting, component integration, database programming, rapid prototyping, numeric and scientific programming, and gaming, images, data mining, robots. You can go ahead and manipulate Excel spreadsheets. Python is really becoming popular within the data mining community. Okay, so that briefly is an introduction to Python. The other thing that I wanted to mention is that Python is an open source system. It enjoys a large and active development community that will respond to issues, and it develops enhancements with the speed that many commercial software developers might find remarkable. Some of its technical strengths are it's object-oriented and functional-based. It's free. It's portable. You can run it on Linux and Unix systems, Microsoft Windows, Mac OS, OS2, VMS, QNX, real-time systems such as VxWorks, Cray supercomputers and IBM mainframes, PDAs, cell phones running Symbian OS and Windows Mobile, gaming consoles and iPods, tablets and smartphones running Google's Android and Apple's iOS, and there's more. It's also a very powerful language. It has dynamic typing, where it keeps track of the kinds of object your program uses when it's run. It has automatic memory management. It has built-in object types, built-in tools, library utilities, and third-party utilities. It's relatively easy to use and easy to learn. That is why currently at most major universities, Python is is becoming the main teaching language when when a student goes in and learns the Intro to Programming classes. At one point, Java was used by most major universities, but now Python is used by most major universities. So this is a brief introduction to Python. What I'm going to be doing in the next video is we're going to be running through the interactive shells. So we will be talking to you in a few minutes.